I'm sorry, but this is your one opportunity until 2079 to be drivable to the path of totality again. So why is it special? Because this path of totality will go through several major cities in the United States, meaning it might be one of the most viewed total solar eclipses in all of human history, because human population is always growing, and because this particular one happens to go through a very populated country, the United States of America, and it hits some really major cities, right? Austin, Texas, Bloomington. And so tens and tens of millions of people will be in that eclipse path on Monday.
Hello, everyone, and welcome to our Ask the Expert event. Today, we'll be learning about the science behind total solar eclipses, discussing safe viewing techniques, and the history behind this stellar moment. I'm Tara Ramsey. I'm NOVA's Outreach Project Manager, and I am thrilled to be here today, only 3 days away from the April 8th total solar eclipse. The excitement is palpable. So thank you so much to everyone for joining us today, including our Champion Circle and Beacon Circle members. We really appreciate your continued generous support. All right, and now let me introduce you to our expert for the afternoon. Grant Tremblay is an astrophysicist at the Center for Astrophysics, Harvard, and the Smithsonian. He was previously a NASA Einstein Fellow at Yale University, a Fellow at the European Southern University, and an astronomer at ESO's Very Large Telescope in Chile. He's currently the Vice President of the American Astronomical Society. Dr. Tremblay's research uses data from the world's most powerful ground and space observatories to better understand star formation amid energetic feedback from supermassive black holes. He's the author of 2 books for the general public, as well as a forthcoming book, Remain in Light, The Once and Future Great Observatories from Princeton Press. He's a regular main cast member on Discovery and Science Channel documentary series, including How the Universe Works, as well as many projects from the Smithsonian Channel, the BBC, and he's also featured on our most recent NOVA episode, Great American Eclipse, which aired this Wednesday and is available for streaming online. We will share the link to this video at the end of this stream. So now, without any further ado, it's my pleasure to introduce you all to Dr. Grant Tremblay.
Hey, Tara. Hey, friends. I really appreciate this. Really happy to be here.
Awesome. Thank you so much for joining us. I think I speak for everyone here that we're all just super excited for this eclipse and excited to learn more about the science behind it. So my first question for you, before we dive into our audience questions, is have you ever seen an eclipse before? And if so, what is that experience like as someone who studies stars and astrophysics?
Yeah, so I was a kid in I think like 3rd or 2nd grade, and I did see a total solar eclipse, and I only like liminally remember it, and those like faint images from childhood. But I do remember seeing what we call the corona, which we'll probably talk about during this hour, and it really is majestic. So I was just a kid. I've seen plenty of partial solar eclipses, but yeah, I saw a total when I was a kid.
Awesome. That's so cool. What a cool experience for kids to get to see something so epic. What are your plans for this upcoming eclipse?
Yeah, so I have 3 kids. I'm going to take my 2 oldest kids up to Maine by Rangeley, Maine. And I'm doing this AAS, American Astronomical Society outreach event up there with a bunch of school kids, but I'm bringing my daughters too because I want them to see it.
Oh, awesome. That's so exciting. And it looks like you might have some really good weather in Maine. Fingers crossed for
We'll see. Yeah, it's hard to predict. As you know, we can never control clouds. It'd be a super bummer if we're all clouded out. I think the South might be pretty bad. Texas might be pretty bad. We'll see.
That's where I'm headed. We're doing a NOVA live stream.
Oh, yeah. Thoughts and prayers.
Yeah, thank you. I'm hoping it'll pop out, like a majestic moment of clarity. Right. Awesome. All right. So another question I have is about what makes this particular eclipse unique. What's going on with the sun at this moment, and how is it different from previous eclipses or our most recent eclipse in 2017?
Sure. Look, I hate to spoil it. An eclipse is a shadow, right? The moon passes between the Earth and the sun, and it casts a shadow. The moon is always casting a shadow, right? The sun is illuminating one side of the moon, and the other side is casting a shadow from the sun. Now, because of the weird way orbital mechanics works, right? The moon orbits around the Earth, roughly every 27 days or so. But its orbit around the Earth is inclined by about 5 degrees relative to the plane in which the Earth orbits around the sun once per year, right? So every 27 days, the moon is going around the Earth. And what that means is that because of the sort of chance coincidence you need in order for the shadow of the moon to actually cross the Earth, we get total solar eclipses somewhere on the Earth on average every 18 months or so, right? So somewhere on the Earth, a total solar eclipse is happening. Now, we live on an ocean world, believe it or not. 70% of the Earth is covered in water. So a lot of total solar eclipses are visible only in the mid-Atlantic or the South Pacific, right? And so what is special about this one? The umbral shadow of the moon, that pure dark shadow of the moon, where the moon will completely eclipse the disk of the sun, will pass through the continental United States. Why is that special? Because it's pretty rare, right? If you're standing in one spot on Earth and you never move, you will get one total solar eclipse in your location every 375 years on average, right? And that's a really, really rough number because it's very dependent on where you are, right? That means, the next total solar eclipse that will be viewable from New England, meaning a short drive away, even if you're not quite in totality, but a couple hour drive, you could see totality, won't be until 2079, right? Oh, wow. So you are currently, if folks are tuning in from the Boston area, you are currently only a couple of hours drive away from that dark shadow of the moon, the umbral path that it will trace through the United States. And this is, I'm sorry, but this is your one opportunity until 2079 to be drivable to the path of totality again. So why is it special? Because this path of totality will go through several major cities in the United States, meaning it might be one of the most viewed total solar eclipses in all of human history, because human population is always growing. And because this particular one happens to go through a very populated country, the United States of America, and it hits some really major cities, right? Austin, Texas, Bloomington. And so tens and tens of millions of people will be in that eclipse path on Monday.
Awesome. Super exciting. I was wondering, do NASA scientists or folks who study the sun and star science travel to the mid-Atlantic when there's an eclipse over the mid-Atlantic?
Yeah, totally. So there are some astronomers who are lifelong eclipse chasers. Mm-hmm. And I got to be honest with the audience. Look, the benefit and the value of the eclipse is more societal than it is scientific. And we're probably going to get into the immense science that you really can do with an eclipse, because we just really can't see the corona in its relief when the disk of the sun is visible because of something called dynamic range, right? The disk of the sun is overwhelmingly too bright to actually see the corona, right? So I'll talk probably, if we get to those in questions, about what science you can do during an eclipse, but overwhelmingly it's a societal thing, right? But we astronomers, the cosmos is one of our animating passions of life. And one thing that is really special about an eclipse is, well, you say it's just a shadow. That's right. It's just the shadow, right? But it is a shadow of the moon, right? This astrophysical body that was created in a collision between a Mars-sized object called Theia and the proto-Earth 4.5 billion years ago. That debris, that molten debris from that collision, circularized into our moon today. And it's a wonderful cosmic coincidence that the angular size that our full moon subtends on the sky is almost exactly equal to the angular size that our sun subtends, right? It's pure accident, right? Just because the sun is about 400 times larger than the moon in diameter, but it's also about 400 times further away. And so for pure geometry, for the same reason why if you're in Brookline at Skyline Park looking over the city skyline, the Prudential Center looks really tiny, right? And as you go up close, it gets bigger and bigger and bigger in the sky. Things that are further away look smaller in the sky, right? Awesome. Yeah. So because of that, we get this wonderful opportunity to fully block out that bright disk of the sun and see its majestic corona.
Super exciting. I did hear somewhere, is it true that the moon is actually getting further away from Earth over time so that this type of eclipse will look different in the far future? So
technically, yes, but in the far, 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 gotcha, overwhelmingly far future, probably human civilization will not be around. So the moon is technically drifting away from the Earth, but it's only about 1 inch per year on average.
Okay,
right?
cool.
Right. So the moon is about 239,000 miles away. 1 inch per year. You could do the math. We could do it together right now. But how long would it take for the moon's orbit to get so far out that it would be too small in the sky, such that you would only ever see annular eclipses? It is a really long time from now.
Gotcha. Good to know. All right. Well, with that, let's get into some of our audience Q&A. I see we've already got quite a few questions coming up in the chat. And just a reminder to everyone that if you do have a question, please drop it in the chat. And if you like other people's questions, please give them those upvotes. That way they can go to the top and we'll ask the most relevant questions to Grant here.
Upvote a really bonkers one. Just go crazy. Just a really weird question. I'll try to handle it.
All right. So our first question in the chat is, what will be visible from the Boston area? Will we see a near full eclipse? That's coming from Steve in North Andover.
So Steve, it's a great question. And I have to be honest, because being honest is important. And I hate to break your heart. From the Boston area, we will see a 93% partial solar eclipse, meaning that 93% of the disk of the sun will be covered. So that's going to be super cool. It'll be very cool, but you will see the moon largely graze the sun, and you'll still see a pretty big sliver of the sun remain. So that's a bummer for two reasons. I don't want to undersell it, but it's a little bit of a bummer because it's hard to overstate how overwhelmingly bright our sun is. So for that entire time, you will need a pair of these to look at the sun. And as the vice president of the American Astronomical Society, I am contractually obligated to say this over and over and over again. Do not look directly at the sun at any other time if you're not in the path of totality and you're fully covered, right? The reason for this, and you need to listen really importantly, one of the reasons astronomers hammer this over and over again, don't look directly at the sun, is because if you actually were to try to look directly at the sun, it hurts, but it only kind of hurts. It's the pain is bearable. Please listen to me when I say that. If you are doing that and you're feeling that slightly bearable, uncomfortable pain looking at that bright sun, you are potentially doing lifetime damage to your retina. You are damaging your vision for the rest of your life to look directly at the sun for any length of time. It is not worth it. You're not going to see anything. There's no point. So please do not do it. So because Boston is only 93% covered, we're still going to see that sliver of the sun at all times. You just don't look at it with your naked eyes. You're just going to damage your retina. You always have to have a pair of these on. Okay. I'm sorry. Or if you can't get these in time, and I can tell you where to get them in short order because we don't have many days left. You can also make a pinhole camera. You can just go online and search it. It's, to be honest, not remotely as cool as being able to look directly with a pair of glasses. But if you got to work with what you have, and if you need to make a pinhole camera, just do it.
Great. Yeah, no, it's super important to remember eclipse safety and not do any lasting damage to our eyes. One question we've been getting a lot just at NOVA, we also distributed some eclipse glasses, but how do folks know when it's safe to take off their eclipse glasses? Yeah,
so from Boston, it will not be safe, period, right? Mm-hmm. Because we're at 93% coverage, you're not in the path of totality. If you are in the path of totality, it's hard to overstate, and this is why I hope that some of you, and I know it's really hard to do this for a lot of you, and I get it. But if you can at all get to the path of totality, you could drive for a couple hours in Vermont. The traffic might be really bad on Monday, and I get that folks have jobs and school and life, and you can't exactly take off for 5 hours. But if you can get to the path of totality, it is super worth it because it's hard to overstate the unbelievable difference between a partial solar eclipse and a total solar eclipse. It is to put it mildly, or pun intended, night and day of the experience. This is because the sun is millions of times, the surface brightness of the disk of the sun is millions of times brighter than the surrounding corona, this crown of plasma that extends 8 million miles above the surface of the sun. And it is impossible to see if any bit of that bright disk of the sun is exposed. You're just not going to see it. You need to be in the path for the moon to completely block the disk. And then for those few minutes, like it depends on where you are, but if you're just on the edge of the path of totality, you're only going to get like 1 minute, 20 seconds of totality. You will know when it is safe to take off the glasses. It is this like generational effect. You can feel the temperature drop. The birds go nuts because they have no idea what's going on. You can start to see stars in the sky, which, by the way, are always shining, of course. The stars are always out. But because of something called dynamic range, we can't see them because that sun is so bright. So you can remove your glasses if you are in the path of totality during totality for that 1 minute to 2 minutes to the maximum totality in the United States visible will be 4 minutes, but that's somewhere in Texas, I think. You will know when you can remove them. The sun will go dark and you'll just see that brilliant corona. And then you'll start to see the moon creep away toward the other side. The sliver of the sun will reappear and then just put your glasses on again.
Awesome. Thank you so much. We've got a question from Jane Zimmerman coming from Dartmouth, Massachusetts. How do I know if the viewing glasses I got through Amazon, which have the number ending in 2 and seem to be legit, are really safe?
Yeah, so this is where I need to be careful, right? Because I can't personally drive and vet every, I can't tell you for sure if your glasses are quote unquote safe, right? Overwhelmingly, the ones you buy from Amazon will be safe, but I need to couch that with a big caveat in that I don't know. And yes, I've heard that there are some phony or fake Eclipse glasses on that you can get on Amazon. The ones that are official will have language like this, conforming to an ISO standard, and there are various standards. Some of them will say approved by the American Astronomical Society. Some will say approved by NASA, and some of that language that you get on Amazon is totally fake. They just make it up and put it on there. Look, overwhelmingly, the glasses you purchase will be safe, but this is a hard question to answer because I don't know where you purchased it, and it's hard to inspect, but you'll be able to tell. I mean, put them on. If you put them on just in I can literally see nothing, right? Literally nothing, right? Mm-hmm. And the only thing I would see is if I look directly at the sun, and you'll see the sun as kind of a dim orange disk. And if there's no pain whatsoever and the disk of the sun looks pretty dim, then you can feel pretty safe. But I got to be careful and can't just say, sure, if you got them on Amazon, they're safe, because you never know what's being sold on Amazon. I'm sorry to not be more.
No, I think that's very helpful. Very helpful to know. And yeah, I mean, there's always going to be people out there making phony stuff, but yeah. if you can look at, I think
if it looks like clear cellophane, like, something you'd wrap a sandwich in, please don't use it.
Yeah, definitely don't wear your normal sunglasses, obviously.
No, that's not going to help.
No. All right. Here's a question from John. He says, what are the most important questions we have about the behavior of the sun, and how may this event help us answer them?
Yeah, John, that's a really nice question. So to first order, not to brag as an astrophysicist, but astronomers over the last century and a half have really made unbelievable progress in understanding how stars work, and down to like these exquisitely predictive equations of stellar structure. So that, to answer your question, we know to first order how stars work. Sorry, but we do. There's so much about the universe that we don't know. But one of the things that we've solved at like the 80% level maybe is how stars work in general. But there's that 20%, and I'm probably being a little bit too arrogant or aggressive in saying we know 80% of stars, but there's this sort of like big swath of stars that we just like straight up don't understand, right? And one of the best ways to study stars in the universe is to study the one that is nearest to us, the one that is 93 million miles away, the one that gives all life on Earth its ability to exist, our sun, right? So we study the sun in a number of ways, right? From ground-based solar telescopes, the Daniel K. Inouye Solar Telescope in Hawaii, DKIST, these major flagship observatories, to the Solar Dynamics Observatory in space, to the Parker Solar Probe that is literally touching the sun right now. Its closest to Parker Solar Probe is currently in orbit around the sun. Its closest approach to the sun will be 8 solar radii, right? That is inside. That is literally touching a star. It's literally flying through a star. But one of the ways is through a total solar eclipse. And even though, we're in this modern era and we have incredible technologies and probes around the sun, it turns out that in order to study the corona itself, you need to be able to observe it. And that's really hard to do because the disk of the sun is just phenomenally bright. And so if you've heard of the term dynamic range, like you might have a high dynamic range TV, right? Dynamic range is sort of one's ability to see something incredibly bright and something incredibly faint next to it, right? So one of our big animating goals in astronomy is to image and do spectroscopy of Earth-like planets around sun-like stars outside of our solar system, right? To look at planets that are orbiting around other stars and search for life, right? And one of the reasons that's really hard to do is dynamic range. It's like trying to observe a little firefly next to a giant Hollywood spotlight searchlight thing, right? The big searchlight, the star, is just millions to billions of times brighter than the planet that's orbiting it, right? And so it's just profoundly hard to see that planet. We have a same challenge in studying the solar corona. The disk of the sun is overwhelmingly brighter than the surrounding corona, which is in many ways the most unknown part. The corona is 400 to 500 times hotter than the surface of the sun, right? The surface of the sun is only about 5,000 degrees, but the solar corona, this crown of plasma, can be millions of degrees. We don't really know why that is. And the solar corona is incredibly important in launching what we call the solar wind. And the solar wind is this river of energetic particles that flow in an outwardly expanding sphere at all times, although at varying speeds and composition and densities, depending on solar activity. We don't know how that wind is launched, really. Not really. We know to first order how it's launched. It's the sort of escaping photospheric material that is launched at greater than the escape speed from the surface of the sun. And so it doesn't fall back. It's shot out and it doesn't come back to the sun. It just propagates outward through our solar system. This is incredibly important to understand. I have the note here so I didn't forget, 1859, I can't remember. Yeah, it's the Carrington. So in 1859, we saw the largest geomagnetic solar storm in recorded history. It's called the Carrington event. It happened in 1859 in September of 1859. You should Google it and check it out. The Carrington event was an incredibly powerful solar storm where if it happened again in the modern age, it would possibly knock out a huge fraction of our satellites in low Earth orbit, like a huge fraction. And I don't know what happens to our society when the global internet goes down, but not to be too alarmist, but I bet it's not good, right? The global internet is 2/3 of the global economy. And if planes can't use GPS to fly, and you're looking at the collapse of major pillars of our civilization, because we built a civilization that is now fundamentally reliant on infrastructure in orbit. And if a giant solar storm comes and wipes out all of our satellites in orbit, I don't want to speculate on what would happen, right? But a Carrington event probably will happen again, right? It happened in 1859. It will happen again. I don't know if it'll be tomorrow, and I don't know if it'll be in 300 years. But better understanding how the sun launches these waves of energetic particles to Earth is really, really important. And one of the ways that we can understand that is to better understand the corona, to better understand how that solar wind is launched. And an eclipse is an opportunity to do that because finally, for once, we can actually see the darn thing, see the corona, because the moon so perfectly blocks out the bright light of the sun.
Awesome. Thank you so much for that information.
I'm giving really long answers. I apologize.
No, not at all. That's why we're here for the long answers and to nerd out on sun science. And I guess I never really realized that it could really knock out that many satellites and it'd be like,
100%.
But a solar storm.
100%. Yeah. We operate a satellite for NASA called the Chandra X-ray Observatory. By the way, www.savechandra.org. We have to shut down Chandra during intense radiation storms. In fact, we had to do it just a few weeks ago because we're entering a period of solar maximum where the sun's getting really active. This is another reason why this particular eclipse will be really important because the sun, I don't know if you know, goes on 11-year solar cycles, periods of solar minimum and maximum of activity. And we're approaching a solar maximum, and we just happen to have a total solar eclipse that just happens to pass through most of the continental US, where 10 million people are living. So it's awesome. It's a great opportunity. Yeah. Sorry, go ahead.
Oh, no, not at all. So a lot of people are asking about how to take photos of eclipses, as well as whether they should wear eclipse glasses over regular prescription glasses.
Yeah, so the second answer is really easy and quick. You can absolutely wear your eclipse glasses over your normal prescription glasses, 100%. Yep. Easy. Yes, so please do. I want you to be able to see. So, I mean, you could even theoretically put these glasses on and then your prescription's over, right? It doesn't matter as long as you have this blocking the light of the sun from your retina, okay? The second one is more disappointing, right? So we all have these things, and tens of millions of people will have their iPhones or their smartphones pointed at the sun during the eclipse. My first ask is that you observe the eclipse with your own eyes and record it in the camera of your memory. Because to be totally honest, your pictures of the eclipse will probably be terrible. That's not because you're a bad photographer. It's just because it's really hard to do, and you need really good equipment to get one of those spectacular, frameable pictures of the eclipse. So by all means, take some pictures with your smartphone. You can actually point an iPhone camera directly at the sun. You're not going to hurt it, right? Mm-hmm. Don't bother digitally zooming in. That is not going to work. Also wouldn't really bother taking pictures. So hate to disappoint our fellow Bostonians, but your pictures are not going to be great at all when we are only 93% coverage. We're not going to see a total. So if you take a picture even at maximum coverage, 93%, you're going to see a big bright splotch on your screen, right? You get a little bit better if you can do this over the lens of your camera, and that will help. You can do it, try it. But really, to get one of those spectacular photos, one, you need to be in the path of totality, and two, the really good ones are done with telephoto lenses, and at the front of it is a special solar filter, and usually at the back of it is a professional photographer who knows what they're doing. It's a challenge, yeah. I did see recently a decent article on tips for taking pictures, and I just encourage you to quickly search it online.
Cool. I think in Nova's most recent film, Great American Eclipse, one of the scientists featured on the film held up eclipse glasses to a telescope to show what happens if you look through a telescope with your eclipse glasses on. What happens when you look through a telescope with eclipse glasses on?
Yeah. Okay. You will burn. Yes. Do not look through a telescope with eclipse glasses. Okay. I need to go back. I used to work at a giant observatory called the Very Large Telescope in Chile. Yes, astronomers name their telescopes in funny and obvious ways. This is one of the largest telescopes in the world. It's 4 8-meter class telescopes in the Atacama Desert in Chile. And every night after sunset, we open the dome of the telescope. And we had literally software alarms, and that you do not open the dome in the day, basically never, right? Because if you pointed an 8-meter telescope at the sun, you would get literally a death ray. But we, in general, unless people know what they're doing and there's a proper solar filter on the front aperture of the telescope, we do not point telescopes to the sun. And we especially don't put our eye to an eyepiece, to a special optic that further collects more light from the sun and then focuses it into a really bright spot, because you are creating a mini death ray with that telescope. And if you can watch online, people put solar eclipse glasses to the eyepiece of a telescope that they're about to ruin, by the way, probably because they're pointing at the sun. So they're going to heat it up so much, probably break the internal structure. But you can see it literally burning the eclipse glasses. Please do not look at the sun at all in general without protection, and definitely don't look at it through a telescope unless you know what you're doing.
Awesome. Thank you so much for that reminder. All right. So question from the chat. When I watch videos of the path of totality, it infers that the shadow will cross from Mexico to Canada in approximately 4 minutes. But where can I check how long we have a view of a partial eclipse here in Cambridge? I found out that the coverage will start from 2:15 p.m. until 4:38 p.m. And I don't understand the difference from the 4 minutes to the 2-hour viewing. And can you explain that?
So yeah, that's a very good question. To short order, I don't want to see just go Google it, but there are a ton of resources that will be at the top of any internet search for how to calculate or look up what the exact eclipse will look like in your exact location. One of those resources, and I need someone to check this for me in real time, I think it's eclipse2024.org, but I might have that URL slightly wrong. But one of those resources that's just like that or very close to it will allow you to put in your location, and it will give you a literal simulation of exactly what the eclipse will look like. Now, to answer the question about what is this 2-hour window, the 2-hour window that they're giving you, the sort of roughly 2 p.m. Eastern time to roughly 4-ish p.m. Eastern time window is the time when at least part of the moon will be in front of the sun. So the partial coverage of the transit of the moon across the sun, from our perspective, or from your perspective, wherever you are on the Earth, will begin in the Cambridge area. I don't have this right off the top of my head, but it's around 2-ish p.m. That just means that the moon will slowly start to transit across the sun. And then it's really around 3:20 p.m. that you'll get the maximum coverage, which for us in the Cambridge area will be about 93%. And then it will take another, 40 minutes or so for the moon to escape the sun, to sort of leave the sun path, right? So that's what that 2-hour window is. So that shadow of the moon, the shadow of the moon will transit from Texas all the way to northern Maine, and it will travel across the surface of our country at about 1,500 miles per hour. It's pure geometry, but it's a demonstration of the fact that this is an enormous body that is 239,000 miles away. The moon is about 2,160 miles across, and it's 230,000 miles away from us. And so that shadow that it casts, the umbral shadow, moves really quickly across the surface of the country. And that is a weird combination. It's a complex combination of the fact that the Earth is rotating, the moon is rotating, and all of that perspective is simultaneously changing at the same time. That's why the shadow moves so fast.
Wow. Awesome. This is a personal question. I'm wondering what determines the direction of an eclipse. I know the eclipse in 2017 kind of moved from west to east, and this one is more diagonal south to north. What determines that?
Yeah, this is hard to show without a movie or without. It's really hard to describe in words, but you can just picture it. So the sun is here, right? The Earth is orbiting around the sun in one plane, and then the moon is orbiting around the Earth much, much more rapidly every 27 days in a plane that is inclined 5.1 degrees relative to the plane that the Earth is orbiting in. So the direction that the eclipse takes place in, it's dependent on what node you're catching the eclipse on. And so that's an unsatisfying answer. My only suggestion would be to look up there are plenty of movies on YouTube. I'm sure on Eclipse 2024, there's a little movie of it. And that is what determines the direction. I know that's unsatisfying, but I really can't show it without showing you a diagram or a movie, because it's just geometrically a little bit hard to imagine. But yes, that is the answer to your question.
I was wondering because, it definitely seemed different than the previous one. And of course, we have plenty of NOVA resources and NOVA documentaries as well with great visuals. So definitely check those out after this broadcast. Here's a question from May Malat. Sorry if I'm mispronouncing your name there, May. Do you have any recommendations on how to obtain the best view if cloud coverage is predicted?
Yeah. It's really hard. The sun is really bright. And from Boston, if we're going to be cloudy, you're still probably going to see the sun peeking through clouds. And it can be such that if you have a lightly cloudy day or even, an overcast day, you can still look with your glasses and you will see the crescent of the moon It's a hard question to answer because it depends obviously dramatically on how cloud cover, how much cloud cover is there. There will be places in the path of totality where the cloud cover is so complete that people will have gotten on airplanes and booked $1,800 a night Airbnbs and will miss the whole thing. And that's a total bummer. Yeah, I'm really sorry. So if cloud cover is predicted, I would just recommend it. Just go out and try, and we'll see.
What are things that people can observe? Like if there is cloud cover, what are the things you can still observe about a total eclipse?
Yeah, so it depends. So during an eclipse, the shadow cast by things like leaves on trees will actually show the crescent of the moon. It's super cool. It's pure geometry. It's kind of amazing how it works. So you could try to do that. Yeah, it's really hard to tell you what you should do if there's a lot of cloud cover. The answer is it's probably just going to be a bummer. But I would just recommend just go out and try, check out the environment, check out what the birds are doing, because the birds do get a little bit more confused during a really, really intense partial coverage. But when they go nuts is when it's a total coverage. Yeah, it's unsatisfying answer.
No, that's all right. How much darker does it get during an eclipse compared to like normal daytime hours?
Yeah, dramatically darker. We could look it up, but it looks like you're in late twilight. Meaning you can start to see the stars. It looks like night. Very briefly, it will look like basically night. You will get a little bit more light than usual because the solar corona is still illuminating us, right? And at night, it's much darker because the sun is obscured by the rest of the Earth, right? The sun dips below your horizon of Earth, and it's illuminating now the backside of the Earth from your perspective. So the sun is not in the sky at night, but during a total eclipse, the moon is blocking out most of the sun, but not all of it. The part that's remaining is the corona, and it is still immensely bright. So it's not quite as dark as night is, but it's just this really magical moment. Because you haven't really quite seen a darkness like this, because it's like late twilight and you get this incredible crown of plasma in the sky. During totality, in Boston, it's not going to be like that. It's going to look like day, maybe just a tiny bit perceptibly darker, but it's hard to overstate how much that remaining sliver of the sun at 93% coverage will illuminate the sky. The sun's really bright.
Yeah. Wow. It also can there can be temperature shifts due to a solar eclipse as well. Can you speak a little bit to what's happening there how dramatic can we expect for a temperature shift in totality?
Yeah, in totality, there is a real temperature shift. It depends, of course, on the local conditions, but it's not a surprise. I mean, when the sun disappears from the sky, the ambient air cools down, right? It's of course, right? The sun is enormously bright and hot, right? And it is the source of our internal temperature on Earth, really, in many ways, right? Internally on the Earth, of course, we have a molten core, this spinning dynamo. But the flux from the sun, the energy per square centimeter of solar photons, particles of light that arrive on Earth, warm things up, right? They keep us hot, they keep us warm, right? And so when the sun disappears from the sky, yes, it cools down. So the degree to which it will cool down in the path of totality depends overwhelmingly on what the local weather is and the ambient temperature and what the winds are doing and the pressure systems. So it's hard to tell. It's also a very short, brief moment that the sun is completely eclipsed, between 1 minute-ish to 4 minutes at maximum. And so the temperature drop is small, but it is perceptible. And part of it is probably, frankly, the sort of mental effect of it just feels cooler when it's darker. Mm-hmm. So there's definitely a sort of psychological effect there too. And it's hard to disentangle, but you can make actual measurements of a temperature drop during totality, but it's small.
Okay, interesting. So we've got a question from Carlane in Monsoon, Massachusetts. Do you have any suggestions for cool experiments that we can do during the eclipse? For example, I heard that a colander would give multiple sun imes. A colander is a good idea.
Yeah, that's right. Yeah, exactly right. So it's fun to be outside with kids during an eclipse because they've really never seen anything like it, and especially if you're in totality again. But yeah, things will cast really cool shadows. a colander will have these a lot of obscuring surfaces, right? It's a piece of metal or plastic with a bunch of holes drilled in it, or created in it, and all of those holes will let some light through and create this like incredible pattern of shadows that in which you can see part of the moon moving across the sun. It's really amazing. That's really fun. Off the top of my head, in terms of cool educational activities, there are actually a lot of them thought up. For example, at the Center for Astrophysics, we have like this world-leading science education department, and they have a whole kit on this. So again, I hate to always be like, just go to the internet and search it. But I bet if you searched it, there are a bunch of cool experiments you can do with kids of all ages. I just don't have any like amazing lesson plans off the top of my head because I don't work on this stuff. But people much smarter in this realm than me have thought of great lesson plans for sure.
Awesome. Yeah, no, I think the colander idea that's a clever.
It's cool. Yeah, I like it.
Awesome. So I've got some interesting questions about, people are wondering how eclipses, like we've talked a little bit about how eclipses affect animal life, but do they affect plant life? Someone even asked if today's earthquake might be due to eclipse activity.
So I felt that earthquake. I was blown away. I thought it was my washer machine on spin cycle because sometimes it will shake the upstairs of our house a little bit, but we didn't have the washer machine on. So I thought it was going nuts. From the bottom of my heart, there is no conspiracy. That earthquake, as rare as it is, has absolutely nothing to do with the eclipse, period. Nothing. No conspiracy. It just, they're totally unrelated. Sorry, what was the other part of the question?
Well, that I think that answered most of it. I did not feel today's earthquake, but yeah, people were just wondering kind of, what other like impacts that eclipses might have. I did notice one good question, or I thought it was an interesting question about whether tides are impacted by solar eclipses. So the
first order answer to that question is that tides are overwhelmingly driven by the moon, right? So you might know that the moon, it of course is very massive and it's very close to the Earth, and the gravitational force falls off as 1 over r squared, 1 over the distance that gravitating object squared. And so the moon is actually pulling a bulge of the oceans of the Earth up toward it at all times, and the Earth is effectively rotating through this teardrop-shaped ball of the ocean, right? So it depends on your perspective, and it's a little bit semantics, but you can argue that the tides come to us, or that we simply rotate through a tidal bulge due to a tidal force from the moon. So the answer to your question is that there's nothing particularly unique about the fact that every 27 days, the moon travels between the direct line of the sun and the Earth, right? What's special about this is that the lineup of the Earth the exact lineup means that the shadow of the moon just happens to fall across the surface of the Earth and just happens to fall across where we all live. And so nothing unique will happen to the tides or anything gravitational that doesn't happen every single month, right? But it is true, technically, to answer your question, of course, the sun is exerting an immense gravitational pull on the Earth. That is why the Earth is orbiting around the sun. Of course, the moon exerts a gravitational pull on the Earth. That is why we have tides. And when the two bodies are lined up together, formally, the tidal force in that direction is stronger. But it has nothing really to do with an eclipse, so there's nothing particularly unique. The net tidal forces on the Earth are always changing, right? So this cell phone knows where I am on the planet to within a few feet because it's talking to GPS satellites that make a special relativistic correction for the orbit of Jupiter, because the orbit of Jupiter also impacts the orbit of Earth, and the orbit of Pluto, dozens of AU away, of astronomical units away, has a tiny, impossibly vanishingly small, minuscule gravitational tidal torque on the Earth. So the answer to the top question is yes, there is an effect, but it's not unique to an eclipse. Okay, great. And you might have covered this, but why don't we see eclipses happening every month? Yeah, no, that's a wonderful question. It is. Again, I encourage you to go to these eclipse2024.org and check out a movie of what's actually going on. Because nominally you would think, well, if the sun is here and the Earth is here and the moon is going around the Earth every 27 days, why doesn't the moon totally eclipse the sun every single time? And the answer is partly because it's pure geometry is the answer. The orbit of the moon is inclined 5 degrees relative to the ecliptic plane, the plane in which the Earth orbits around the sun. And so you get these weird geometric effects. So to answer the question, a total solar eclipse is visible roughly every 18 months or so somewhere on Earth, right? So it is pretty common. But like I said earlier, overwhelmingly, a lot of those total solar eclipses are visible from the middle of the ocean because most of our planet is ocean. Or a lot of them happen in places where like almost nobody lives, right? Incredibly sparsely populated jungles and forests and tundras and plains. And so, yeah, it on average with a huge error bar, with a huge range of possibilities, a total solar eclipse is visible from any given singular location on Earth every 375 years. Wow. Pure geometry. It's just an accident of geometry.
So wild. We've got some folks wondering, what are pilots going to do during a total solar eclipse? Like if you're up in a plane, obviously we don't want them putting on eclipse glasses while they're flying a plane.
Well, technically, I hate to tell you this, most planes fly in autopilot, right? And that the pilot is actually only commanding the aircraft during takeoff and landing. So to be super honest, if I were a pilot at 37,000 feet during a total solar eclipse, I would 100% have a solar eclipse glasses on because that would be an incredible sight. I think that there's even a commercial Delta or a United Airlines flight or something that is specifically meant to be the best possible path through the eclipse. Wow. So you can see it from 37,000 feet. And you can Google some photos of total solar eclipses that were taken at very high altitude, and they are stunning, like just magical. Wow. So if I were a pilot and an aircraft that could fly itself, I'm 100% looking. I'm sorry.
That's awesome. Yeah, no, I guess I didn't think of that, but the idea of a pilot with eclipse glasses on, I love that.
Yeah.
I wonder how much those tickets cost to be on that plane.
Yeah, I don't know. I heard about that flight. It sounds awesome.
Awesome. So we do have quite a few people asking if they need to wear the eclipse glasses the whole time. Just to kind of reiterate this point, when can you take your eclipse glasses off?
If you are in Boston and you are not in the path of totality, you cannot take the eclipse glasses off. I'm sorry, but I do not want you to damage your eyeballs for the rest of your life because they are very useful. And it is 100% not worth it to take them off and look at the sun. That is only 93% coverage. You're not going to see anything. You're just going to hurt your eyes and you're going to see this blinding white light and you're just not going to see anything. Just don't even bother. There's no point. You're only going to do damage to your retina. The time when, if you are in the path of totality, if you're driving 3 hours to Vermont on Monday, I promise you it will be bloody obvious when you can remove your glasses for that brief minute or so, because the sun will disappear and you will see this brilliant, majestic crown of plasma, much, 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 much fainter than the sun itself. And it will also be obvious when you need to put them back on again, because the moon will start to escape that disk. That bright rim will suddenly reappear. Your eyes will start to flinch. Just put them back on again.
Mm-hmm. Great. Thank you. All right. Bernadette Manning from Cambridge says the shadow starts as a circle when it starts in Mexico, but when it gets to Canada, the shadow becomes an oval. Could you explain?
Yeah. Again, it's pure geometry. So two things about shadows. I don't know where you're sitting right now, but if you'll notice, everything that's casting a shadow is actually casting both a penumbra and an umbra. This is much cleaner to see when you're in a darker room and you have one singular light source, like at nighttime and you only have a bedroom lamp on. Notice things that are on your floor, like, I don't know, like the legs of chairs or the edges of doorways. There will be a dark part of the shadow called the umbra and a fainter, fuzzier part of the shadow, sort of a fuzzy edge to that shadow called the penumbra. Boston will be in the penumbra of the moon during the eclipse on Monday. What that means is that from the perspective of something sitting in the penumbra, the source of light that is casting that shadow is not 100% blocked by the thing that is casting the shadow, right? And so it's you can almost demonstrate it right now. I can't do a clean experiment like on Zoom right now, but The reason why the shadow, the umbra of the moon will be almost a circle down south in Texas is because if I were to okay, this is very, very janky ad hoc experiment. I'm turning my light on. This thing kind of casts a shadow, even though it's transparent, so it's not a great shadow. But as I move the perspective on this flat surface, I can make an oval shadow from this circle. Do you know what I mean? This is a really bad demonstration. But just try, making shadows with a circular object in your house and change the perspective at which you do it. And you can easily create an oval shadow just based on pure geometry. And remember that the Earth is a round sphere and the surface of the Earth just curves away from the perspective of the moon. And this is why the shadow will become an oval as that shadow transits across the continental US.
Awesome. That makes sense. So the closer to the equator you are, the more circular.
In this case, yes. Yeah. Mm-hmm. It's just how things line up, and it's really hard to describe in words. You kind of have to look at a picture or a diagram or a movie to kind of get the geometry of it. It's hard to describe.
I've got another question about solar eclipse glasses from Charlene Barron. Are eclipse glasses used in 2017 still effective?
Oh yeah, totally. Yeah, they don't expire. I'm sorry, they don't expire. And if they write an expiration date on there, look, they're probably fine.
Awesome. Good to know. Because yeah, I've definitely heard conflicting information about that.
I don't want to get emails from lawyers as a double ASVP. Look, I think you're probably fine, right?
Great.
Let me just say that.
Let's see. Kathleen Bellici asks, in the few minutes leading up to and after a total eclipse, in my experience, the sound is somewhat muted and the shadow appears to erase sound. Is that a personal experience or is it real? Is there anything going on?
Yeah. So in terms of, look, the sound you hear, because sound is a matter compression wave, right? It's a matter compression wave that's propagating through the air. And it hits your eardrum, which causes your tympanic membrane to vibrate, which, I'm not a doctor, but triggers these nerve reactions, and then you perceive it with your brain, right? None of that will really change at all with the eclipse. So the first answer to your question is no, the eclipse doesn't do anything with sound, right? There's probably a big psychological effect. I'm not saying, oh, you're all going nuts, you're perceiving something that's not there. But there is a real psychological effect, especially in the path of totality where things might seem to get quieter. And maybe it's because people stop talking and they're looking at the sun and going, ooh and ah, quietly, right? So things might literally get quieter because everyone is, and the birds will go nuts at one point in totality. And so that can make things louder in some ways. I don't know. But no, nothing will happen to first order with sound because of the eclipse. Technically, if I'm going to be a scientist and answer your question technically, normally, the temperature of the air will decrease, and therefore the sound speed in the air, which is a function of the ambient temperature, because this is a matter compression wave after all, will technically change, but that is not perceivable, 100% not perceivable by human beings.
Awesome, great. And I think we have time for maybe one more question here. Let's see. What questions are scientists hoping to answer by examining the corona is a question that's come up several times.
Yeah, it's a great question. I encourage you to go to the Wikipedia page for solar corona, because it's really a remarkable story. I mean, there was once, a couple centuries ago where folks during total eclipses thought the corona was part of the moon. Yeah, so the corona is this 2 million degree Fahrenheit, these ribbons of plasma that are riding these magnetic field lines that soar millions and millions of miles above the surface of the sun, meaning they're much, much longer than the sun is, the disk of the actual physical disk, the photosphere encompassing volume of the sun is wide, right? Meaning the sun's diameter is 865,000 miles across. But the corona, these flares of plasma can extend for millions of miles beyond that. And we really don't know how it works in so many ways. it's hard to overstate how little, we don't really know for sure why it's so much hotter than the surface of the sun. There are really good, we've had really good advances, especially in recent years. The Parker Solar Probe, which the Center for Astrophysics here in Cambridge, actually, we built an instrument for it. So an instrument that was built in Cambridge, Massachusetts, is currently like basically inside of the solar photosphere right now, right? Not the photosphere, but the corona. Yet there's so much we don't know about the corona and how it launches the solar wind, what its structure is, what its periodicity is, how it's coupled to magnetic activity of the sun, which we really do understand to a larger degree. We understand the 11-year solar cycle pretty well. We're understanding sunspot cycles pretty well. But the predictability of major solar events is only reliable on short timescales. And then again, on this 11-year periodicity. But the really big events is sort of X-class solar flares and the potential of a possible future Carrington-level event that could knock out satellites. We really don't understand how and why and when they're launched. And understanding the corona is a keystone in better understanding that.
Awesome. Well, I think that is about time. Thank you so much to Dr. Grant Tremblay for joining us for this GBH Ask the Expert event. Some great safety tips today. So thank you again so much, Grant. And yeah, thank you to everyone for joining us today. Have a wonderful eclipse, everyone.